we are looking at some special case factoring. What I want you to remember is that if something is factorable, you can always factor it using crisscross factoring. So if these shortcuts that you're going to see today don't quite connect with you, but you really understand special case or crisscross factoring, then don't worry, you can use that method there. Okay, so with special case factoring, we're going to look at figuring out what difference of squares are in perfect square trinomials. In the Minds On, you're asked to expand and simplify the following expressions. So I'm going to ask that you pause the video and then go ahead and expand and simplify those expressions. Okay, hopefully you've gone ahead and done that. But if you haven't and you've been a bit stuck, so what you're going to need to know is that you're multiplying the first term with everything in the second set of brackets, and then you multiply the second term with everything in the second set of brackets. So x times x times negative 3, 3 times x, 3 times negative 3. Then you're going to simplify, collect like terms, which are those two middle terms. So that's x squared, well, negative 3 plus 3, that's 0. And then minus 9. Do I need to have that 0 there? No, I don't. So I'm just going to say x squared minus 9. Okay, looking at the second one, we have, again, x squared, x times 8, negative 8 times x, and negative 8 times positive 8. Combine those two middle terms together, you get the 0, but we know we don't have to write that. Okay, so what do you notice about the middle term of each equation in the standard form? What happened to the middle term? Well, it's gone. What do you notice about the first and last terms? X squared, and let's just ignore the negative for a second, and 9. X squared and 64. You can take a square root of x squared. The square root of x squared is x, because x times x is x squared. Again, we're just ignoring the negative for a quick second here. You can take the square root of 9, it's 3. And you can also take the square root of 64, it's 8. So you can take the square root of each of them, and that's really important here for this shortcut. This is what we call a difference of squares. Difference meaning subtraction, and squares, well, two perfect squares. So that's the shortcut we're going to look at. The last question says, what do you notice about the numbers in factored form of each equation? So here's the numbers in factored form of each equation. They're the same number, it's just one's a positive and one's a negative. And that's really important because when we have the same number, one's positive and one's negative, and we expand it out, what we're left with when we simplify is 0. So that leads to this middle term going away. Here's some examples for you. For the first one, I've put in the 0 here because if you recognize that you have, a squared term and then a constant, but you don't have a middle term, if you wanted to put 0 in, and that will allow you to use the crisscross method. So if I'm using the crisscross factoring method, I could say, well, what two numbers multiply to x squared? Just x and x, right? what two numbers multiply to -9? -9, +1, or sorry, 9, +1, -9, -3, +3. And of these, what adds to 0? And there it is there. So you can quickly gather that information and write out your factored form equation. However, if you do this, this method, it's just a little bit slower. You can also say, well, I know that the reason why I'm missing the middle term was because the number that I'm adding and subtracting in the brackets, oops, one was positive and one was negative, but they were both the same number. What were they? They were the square root of the second term. Square root of 16 is 4. The first term has to be, and I'm sorry, I kind of skipped over that. The first term has to be the square root of this here. So what I'm doing is I'm thinking, well, what is the square root of x squared? And that's x. What's the square root of 16? And that's 4. And that's where these two terms come in. Okay. Now looking here, I can get the square root of 16. I can get the square root of x squared, and I can get the square root of 100. But I can also have to remember that the first thing that I should be doing when I'm factoring is check for a greatest common factor. And I know that I can divide 4 out of both of those terms. So I would have y equals 4 out front. 16 divided by 4 is 4. 100 divided by 4 is 25. So I've got minus 25. Now I can say, okay, well, what's the square root of 4x squared? Can I get that? Yeah, 2x. 2x times 2x is 4x squared. Could I get the square root of 25? Yeah, that's 5. And because I can get the square root of the first term and the square root of the second term, and there's subtraction in the middle, that's what makes it a difference, subtraction, of 2 squares. Here's the 2 squares. And I can quickly write that out by saying, well, there's the 4. I have 2x at the start of each bracket, and plus 5 in one, minus 5 in the other. And that's kind of the quick way of looking at it. Okay, so here's the rule. If you have a squared minus b squared, basically that's in standard form. That's the same as a plus b, a minus b. And you want to check to see, can I get the square root of a squared? Can I get the square root of b squared? Okay, because if I can get the square root of both of those, it's a difference of squares, and you can quickly use this strategy. You give it a try. Pause the video here and try that out. Okay, hopefully you've given that a try, and if you have, you should recognize the square root of x squared is x. The square root of 49 is 7. So I have a subtraction with 2 squares. That means I've got x plus 7, x minus 7. If I took the square root of 150, I'm not going to get a very nice number. I can't get the square root of 6 and get a nice number either. I could get some decimals there. But remember, first thing with factoring, check to see if you have a common factor, and 6 goes into both of those. So I'm going to factor that 6 out. That leaves me with x squared minus 25. Okay, well, you guys can probably see this already. The square root of x squared, well, that's x, so I've got a square there. Square root of 25 is 5. So I've got 2 perfect squares, and I've got a minus, so that's a difference of squares. And here is how I would write it. Now, don't forget to put that 6 there, because that's a part of this quadratic function. Okay, so that's a difference of squares. The other shortcut that you can do is perfect square trinomials. Okay, so here's perfect square trinomials. This one here, you have to remember that you've got, what happens when we have the square here is that we have to expand both of these out, right? So, or sorry, this bracket times itself is what I should say. It's not x squared plus 36, it's x plus 6 times x plus 6. We've done this a lot, so that's going to be x squared plus 6x plus 6x plus 36. And then these two middle terms combine together to make 12x. So now we have x squared plus 12x plus 36. Okay. Next one, we have x minus 6, x minus 6. So that's x squared minus 6x minus 6x plus 36. Okay. We've talked a few times again about how to expand and simplify. Here's the simplifying. Those two middle terms combine to give me negative 12x. Okay. Last but not least, here's one that's got a little bit more going on in it. We've got 2x plus 5 times 2x plus 5. 2x times 2x, 4x squared. 2x times 5, 5 times 2x, and 5 times 5. Oops, 25. Combine those middle terms, and we get 20x in the middle. Okay, so here's this pattern. If you notice, that middle term is 2 times the square root of this term and the square root of that term. Okay, so if I find what the square root of x squared and the square root of 36, if it's a perfect square trinomial, that middle term is going to be 2 times the square root of both of these. 2 times x times 6 is 12x. And that's ultimately what you're looking for. Sometimes it's positive, that gives you a positive answer when you factor. Sometimes it's negative, that gives you a negative answer when you factor. Okay, let's have a look at that again a little more closely with these next examples. I'm going to check to see if this is a perfect square trinomial. So is it a perfect square trinomial? Let's take the square root of the first term and the square root of the last term. And then I'm going to say, well, is 2 times this x times that 3, what does that end up equaling? 2 times x is 2x times 3 is 6x. And if it's a perfect square trinomial, this right here will be the middle term. And in this case, it is. So when we have a perfect square trinomial, we can quickly write it as, well, technically it's, we can quickly write it as x minus 3 squared. Okay? So this would be the first term, this would be the second term in the brackets, and then it's minus because the minus is here. If that went a bit too quick for you, let's just do that simple trinomial factoring in the middle. Two numbers that multiply to positive 9 and add to negative 6. That's x minus 3 times x minus 3. And so that's another way that you can see to get there. Okay. Again, we'll check to see if this is a perfect square trinomial. So can I common factor? I can't, I would only have 1, 2, and 4, and none of those come under 25. So I can't common factor here. Just just move this up a bit. So let's take the square root of 25x squared and the square root of 4. And I'm going to say 2 times this root times this. So 2 times 5 is 10 times 2, that's 20. And then we have the 1x in there, so 20x. And because that's the middle term, I can quickly write this out as a perfect square trinomial. Or I can recognize it's a perfect square trinomial, and I can write it out in factored form by just saying, well, 5x and 2. And I have to figure out, is that a plus 2 or a minus 2? For that, I'm going to look right here. Okay, this one was minus, this one's plus. Okay, last example. Is there a common factor? Yeah, I can factor 2 out of all of those. So I'm going to divide everything by 2. X squared minus 8x plus 16. I'm going to take the square root of the first and third terms. Square root of x squared is equal to x. Square root of 16 is equal to 4. And if I go 2 times x times 4, that indeed gives me that middle term right here. Okay? So that means I can write it out as a write it out in factored form. I'm going to have x from here, 4 from here, minus, because it's minus here, and then it's squared. So I forgot to put a little squared on that one back there too. Okay, here's the kind of rule. If you have two perfect squares as your first and third term, and the middle term is 2 times the root of the first times the root of the third, then what we're going to have is a perfect square trinomial, and you can quickly write it out as a, b, and then check this middle sign here, and that will tell you what to put in the middle.